Now we go on to the applications of vectors to geometry. Now here we will be proving a lot of results from the elementary geometry that we might have studied earlier. But we prove these results with the help of vector approach now. Okay, so we'll see how simple the proofs become when we employ the vector approach. Now the first result is that all medians of a triangle are concurrent. That means all the medians pass through one single point. So let's consider a triangle, a general triangle. A, B and C are the vertices. Let's draw the medians. Let's name the respective midpoints as D, E and F. So D is a midpoint, E is a midpoint and F is a midpoint. And for any triangle, all the medians are always concurrent. They always pass through the same point. Now we have to prove that these three medians pass through the same point. Okay, and that point incidentally is called as the centroid of the triangle. Now we take up the case of one median and we derive or follow the similar process to get the information about the remaining two medians also. So let's consider median AD. Okay. Now here, since D is the midpoint of side BC, by the midpoint formula we can write that D bar must be equal to B bar plus C bar upon 2. Correct? So that means that gives us 2 times D bar is equal to B bar plus C bar. Now here at this step we use one important trick, that is, see on the right side we have B bar plus C bar. So to complete the set of A, B and C, the missing vector is A bar, right? So that is what we add on both sides. So therefore we get 2D bar plus A bar is equal to A bar plus B bar plus C bar. And then we divide both sides by 3 for the reason which will be clear immediately. So we have 2D bar plus A bar upon 3 is equal to A bar plus B bar plus C bar whole upon 3. And now you see how we write or rewrite the left hand side. It's 2D bar plus, we purposefully write A bar as 1 A bar divided by 3 is written as 2 plus 1 is equal to, right side remains unchanged, that is A bar plus B bar plus C bar whole upon 3. Now if you look at the left hand side, clearly we identify that it is the section formula for internal division, and it indicates the position vector of that point which divides the segment AD internally in the ratio 2:1. Alright. So there is some point. So that point is represented by, say, G. Okay. So that means whatever position vector we have obtained or whatever vector we have obtained on right side, that represents the position vector of that point which divides AD internally in the ratio 2:1. So let us call that as, say, G bar. Now what we did for median AD, the same we can do for the remaining two medians also, that is BE and CF. And because of the cyclic symmetry, we will obtain the exactly similar patterns in those medians also. So that means in case of BE, we will obtain 2 times E bar plus 1 times B bar whole upon 2 plus 1 will also be equal to the same vector, that is A bar plus B bar plus C bar upon 3. And in case of CF bar, we will get 2F bar plus 1 C bar whole upon, once again, 2 plus 1, which also gives us the same vector. That means there is one point which is lying on all the three medians, and hence it means that all the medians of a triangle are concurrent, that is they pass through the same point. And the expression that we got is nothing but the expression for position vector of the centroid of the triangle.